This is the NEET 2013 question from rotational dynamics. Problem is like this. A rod PQ of mass M is hinged at the point P. So you mean to say it is fixed about this point. Fixed about this point. Whose mass is M. So obviously its weight always acts in a vertically downward direction. Rod is kept horizontal by a massless string tied to a point Q as shown. Here is a string. When the string is cut, he is saying that if I break this string, break it. What is the initial angulation? What happens when the string is cut is this rod will try to rotate about this fixed point with an angular velocity alpha. I have to calculate how much is that, right? So if I have to calculate torque, we have a formula for the torque as I alpha, where I is moment of inertia of this rod about the axis passing to the edge of the rod. For that we have a formula, moment of inertia of the rod about the edge is ml square by 3. Be careful, if the rod is having axis from the center, its moment of inertia is ml square by 12. But about the edge means it's a parallel axis. Distance between them is half the length of the rod. This is moment of inertia about the center of the gravity. You want to calculate I. I can use the parallel axis theorem. I equal to Ig plus mr square, where r is the distance between two parallel axes. Ig is ml square by 12. M, r, distance between the two parallel axes is L by 2 whole square. So ml square by 12 plus ml square by 4. 12 is the LCM. Ml square here. 4 is of 3 times. It is plus 3 ml square. So 4 ml square by 12. That is ml square by 3. Moment of inertia of that has to be calculated that way. How you get this ml square by 12? Of course, I have derived it in the list of the rotatory dynamics. That's the standard derivation using integration. Please go through that once. Knowing this moment of inertia now, I have to calculate alpha. But you know that torque equal to I alpha is force into perpendicular distance. This string will have a tension T. Perpendicular distance is acting from weight to the edge of this. That is half the length, L by 2. Tau into L by 2. So let us substitute the data. I is ml square by 3. Alpha I have to find out, right? Tension is the I have missed something. It's not the tension. The force acting is mg and the perpendicular distance is L by 2. So in the place of tension, actually I had write mg and L by 2. So m and m will cancel. One L also will cancel. So what is remaining is L by 3 of alpha equal to G by 2, right? So alpha equal to 3G by 2L. That's the answer. That's the answer. That's how I solve. I have to solve the problem. Be careful. Here the torque is developed on this rod. On this rod, the torque is developed due to this weight, mg acting, and this is the string that is attached, and this perpendicular distance is L by 2. So torque is force into perpendicular distance. Force is mg, perpendicular distance is L by 2. So mg into L by 2. That's how we get this answer. Thank you for watching.